Hey peeps, it's Jedd here from Disrupt Tutoring, and as always, it's such a pleasure to join you. Today we're going to deal with a maximizing question, and we've taken this one from the IEB's 2019 Supplementary exam. In the diagram, triangle ABC is a right-angled triangle with hypotenuse 10 root 5 and BC, etc. The triangle is rotated about BC to form a right circular cone as shown in the diagram. Calculate the maximum volume of the cone. Okay. So we've got this cone and they've asked us to find the maximum volume for it. They've given us the volume of the cone, and essentially all we need to do is find the R and the H, plug it in, and then to maximize it we're going to find the derivative, equal that to 0 to find the maximum, and then we will be able to find the X value at which the cone is at its maximum volume. And once we've got that, we can plug that X value back into our equation, the initial equation, and find the maximized volume of this cone. Right, with that in mind, let's dive straight in. So I'm going to start off with the volume, and that's going to be 1 over 3 pi r squared. Now r squared, I'm going to put that there, r squared height. Right, so let's see what we can plug in. The r squared, what would the r squared be? It would be this BC over there. We've got the circle at the bottom, and we've got BC over there. That's our radius. So that would simply be 475 minus 10x minus x squared, and that is to the half, and we know that whole thing is squared. All right, and then we've got height. Now the height is the tricky one. We don't actually know what the height is. They haven't given us AB, but fortunately, and we did this in grade 8 back in the day, fortunately we can see that that's a right angled triangle. So we're going to use a bit of Pythagoras to find out what that AB side is. Right, so we know Pythagoras is the square of those two sides. We add them up, and that would equal the square of that side. So we can rewrite this as AB squared is equal to 10 root 5 squared, and it would be minus, and that whole thing squared, 475 minus 10x minus x squared, and that's to the half, and that whole thing is squared. Right, moving on to the next step, AB squared. How do we square this? So we square the 10, that gives us 100. We square the square root of 5, that gives us 5. And then we've got minus, the square and the half cancel out, so we're left with minus 475 plus 10x plus x squared. Remember to multiply that negative in. Right, on to the next step we go. We've got AB squared equals 100 times 5 gives us 500 minus 475 plus 10x plus x squared. Right, we're almost at the base of this one. And on to the next step, AB squared. So 500 minus 475, that's going to give us 25. Then we've got plus 10x plus x squared. Right, now we're going to factorize that right-hand side, and I'm going to do it right next door. And that's going to give us AB squared. And when we factorize it, we're actually going to find that it's x plus 5. So 5 plus x squared. We're going to square root both sides, which gives us the plus and minus. But we know we need to have a positive value here because we're dealing with lengths. That's going to give us AB equals 5 plus x. Right, so that is, what have we been looking for? AB represents the height of that triangle. So now we can multiply that height in. All right, because I've run out of a little bit of space there, I'm going to put a little h there, and I'm going to move down to the next step. Right, I'm going to clear out some space and then finish off this question. Right, I'm going to leave that in for now. Right, so the next step, I'm going to say, right, V is equal to 1 over 3 pi, and then we've opened up that bracket. Can we get rid of this bracket now quickly? I think we can. Let's do that. So what do we notice? We've got a square over there and a half over there. Those two cancel each other out, and we are left with 475 minus 10x minus x squared, right? And that gives us the simplified version there, and we plug in our h, and the h here is 5 plus x. Remember these brackets. Don't get confused with these brackets. You've got to include them. Really, really important that you include them. Right, now we can times that out. And what we're going to do there is we're going to use our type of FOIL. But in this case, we're going to multiply that by both terms in that bracket. We're going to multiply that by both of those in that bracket. Then we're going to multiply that by both of those in that bracket. And once we've done that, we're going to find ourselves at a point of minus 1 over 3 pi x cubed minus 5 pi x squared plus 425 over 3 pi x, and then we've got plus 2375. So we've got 2375. So it gets us to that point, right? So once we've multiplied this out and we've simplified it, we get that expression. Now we've found an expression of the volume of the cone. But now they've specifically asked us to find the maximum volume. So where will the volume be its maximum? It will be where the derivative, okay, the derivative equals 0. So right, let's find the derivative. So we're going to look for the derivative of v with respect to x. Right, so let's do this quickly. We're going to use our exponent laws. We're going to use our exponent laws. So we're going to have minus those, that 1/3 and 3 cancel out. So we're going to have pi x squared. Then we are going to have minus 10 pi x plus 425 over 3. That is just pi. And then the last thing falls away because it's our constant. Now remember, it's at its maximum. So at max, we're going to say that the derivative equals 0. Right, so that would therefore mean that 0 is equal to, I'm going to simplify it straight away. How can I simplify this in a first step? Well, I'm going to pull out this pi, and I'm going to factorize the pi, and that is going to give us minus x squared minus 10x plus 425 over 3. Okay, what I should have probably done here, and it's always good to learn from my mistakes, is to make my life a little easier. What I'm going to do is I'm going to pull out this minus x, or this minus 1 as well. So luckily I can just erase. That becomes a plus. This becomes a minus. So once I've pulled that out, at least I've got a positive coefficient there, but I must remember to have the negative pi on the outside of the bracket. Right, so now I need to solve for x. What do I do first? Okay, so I'm going to get rid of this pi by dividing both sides by pi. So I'm going to essentially be left with 0 is equal to x squared plus 10x minus 425 over 3. Right, so now I can see I've got a trinomial. Okay, so I've got a quadratic equation where I'm expecting two answers. I'm expecting two answers for x. Okay, so I've got two options here really. I can use my snazzy silver calculator to calculate the two values, or I can use my quadratic equation. And the quadratic equation you can find on the formula sheet, and you would simply plug in the a value, the b value, and the c value, and you'll get your two values of x. So here in this case, we're going to find that x has some decimals. So x is approximately 7,9, or x is going to be approximately 17.9. But now we know, because we're dealing in sizes and lengths, we're not necessarily worried about the negative number here. Sorry, I actually didn't put in the negative number there. Right, so that's going to be negative 17,9. Right, so we're not interested in the negative number here. We're only interested in our positive number. Right, so are we done? No, we're still not done. Okay, it's quite a long question. So what do we do next? Well, we need to find the volume at that maximum point. So all we're going to do is we're going to take this x that we've calculated, and we're going to subs it into our original volume formula. Okay, so we're going to subs it into our original volume formula. And once we've done that, we're going to get that the volume of the cone is approximately 4,506,42, and we need to make sure our units are there, centimeters cubed. All right, so we take that 7.9, we plug it into our volume formula that we derived right at the beginning, And once we multiply that out on our calculators, we're going to get 4,506,42. What's most important here is that you understand the process, right, of maximizing. So the first thing is write out your formula, see what you're missing, apply Pythagoras to get what you're missing, multiply out to get the volume, then realize that at the maximum volume, the derivative is equal to 0. Find the derivative, equate it to 0, find your x values, understand that only the positive x values are important here. Once you've got your x value, plug it into the original volume formula, not the derivative, the original volume formula, and that will get you the maximum volume of this cone. A very special thank you to our sponsor for making this video possible. Be sure to read all about them in the description below. Also, head over to our website for more of these epic tutorial videos. If you can't find the answer to your question, send us the question and we'll respond with a personalized video just for you. Until the next time, stay epic.